everyone, today we are from Group 1C. We are doing a project regarding vinyl chloride monomer VCM production. VCM is a colorless flammable gas at room temperature. The main use of VCM is to produce plastic. According to OSHA, VCM is classified as a Class 1A flammable liquid. This is because of its low boiling point. Liquid VCM would undergo flash evaporation, meaning it would vaporize to form dense cloud. This is likely to form explosion and severe problems to the workers around the plant. It can be concluded that VCM is a fire and explosion hazard. In today's project, our group is focusing on bubble column reactor in the VCM production. There is two reactants that is entering the reactor, which is chlorine and the other is ethylene. Ethylene is a high flammable and colorless gas, while chlorine is very reactive to human body. So for today's case study, we are going to talk about the leakage of chlorine and ethylene to bubble column reactor. Thank you.
Now I will explain on the hazard analysis on the system. So our group has been choose to study the R101, which is the reactor for the chlorination. So I will explain about the hazard analysis on the reactor. So when we talk about hazard, so we need to decide the parameter. So the parameter that has been decided for this reactor is the inlet flow rate, the temperature inside the reactor, and also the pressure inside the reactor. So for the inlet flow rate, there are like 4 deviation that might occur, which is there are no flow, flow is increasing, then the flow is decreasing, and also reverse flow rate. So this is the deviation that might occur for the inlet flow rate. So in case of no flow, we can assume that there might be like a block, or maybe a puncture in the inlet flow rate pipe, which made that the flow rate doesn't enter the the reactor. So this means that there are release of toxic occur lah. Then if there are more flow rate, then meaning that when more flow rate comes in, it will increase the pressure inside the tank and might become explode. Next, if the flow rate is less, then the reaction inside the reactor might not occur efficiently lah. So we will get a lot of byproduct that we don't want. And last, which is the reverse flow rate. So in case of reverse flow rate, then meaning that there will be no reaction and also no product is being produced. Okay, that's for the first parameter. Next, we move on to the next parameter, which is the pressure inside the reactor. So there are just 2 deviations that might occur for the pressure inside the reactor, which is there will be overpressure or under pressure. So in case of overpressure, the things that might happen is when the tank cannot support longer the pressure, then it will explode. So not just explode, but then the toxic inside or any material that is stored inside the reactor will be released. Next, if the pressure is under pressure, this means that the reaction will not become efficient lah. Okay. Last one is the temperature. So in case of temperature is too high, as we know, when temperature rise, then the reaction will increase. However, the reaction will increase too much, which make the pressure inside the reactor itself to be increased, and next over pressure lah, and then explode. Just like the high pressure just now. Okay, if the temperature is lower, then the reaction will not be optimized. Okay, now I will explain some safeguard that can be used for all of these this potential hazard. So for the first, inlet flow rate, we need to check the condition, or put like some sensor or controller at the inlet flow rate, that we can see whether there is flow, or maybe if the flow rate is increased and such thing. So from there we can know what to do and control all the flow rate that might become deviate. So from that we can avoid from having overpressure and such thing. Next, for the pressure, for the pressure parameter, the action that we can take to what call control or avoid the hazard is by putting a pressure and level control. So by having this control or by having this control, we can release the pressure in case of the pressure is too high. So from there we can avoid lah the tank from being released. However, there might be like some circumstances where some toxic material will be released. However, we can control the amount lah of the what you call material release. And for the temperature, we can also the same. We put the temperature controller. So when the temperature rise, we can put some cold water to flow to the reactor so that it can carry out some of the heat so that the reactor not be overheat. So I think that's all for the hazard analysis. Thank you.
Hello, my name is Mohammed Iskandar Hakimi, and I will talk about the source model for two flows of vapor with puncture at pipelines and explosion. For the first source model, we have conducted source model based on the first stream, which is the ethylene stream, while for the second source model is based on the second stream, which is the chlorine stream, while the third stream is about explosion. For these both source model, which is the first one and the second one, 0.2 inches of puncture was introduced to the pipeline. It can be concluded by having three situations. The first situation is when the puncture is unnoticed. If a puncture of 0.2 is introduced to the ethylene stream, the result of probit analysis is 100 people will die from the puncture if it is unnoticed. For the second situation, if the puncture has been realized 30 minutes after it happened, the probit is 88%, which means 70 people out of 20 will die. For the last situation, which is the puncture has been realized after 10 minutes, the probit is 53%, which is around 10 people will die. For the second study model, the same three situation has been introduced. The first one is when the puncture is unnoticed. The second one is when the puncture is noticed after 30 minutes. And the last one is when the situation of the puncture is noticed after 10 minutes. All these three situations will have 100% of probit, which means all 20 people will die. For the third stream, which is the product stream, dichloroethane, three situations has been introduced to know the worst case scenario if explosion happens. For the first situation, assumption has been made, which is people in the reactor is roaming around it around 30 meters, and the probit for lung hemorrhage and eardrum rupture is 100%, which means all 20 operators will die. Meanwhile, for the second situation, we assume that 8,000 kg of TNT is contained by the reactor, and the reactor is a flat surface. The probit for death due to explosion is 0%, while 27% will suffer from ear rupture, which is 10 out of 40 people. For the last situation, we assume that what will happen to the people nearby the reactor if the reactor contains 8,000 of TNT and the reactor is a flat surface. The probit shows 0% of either death or ear rupture will happen to the people nearby the plant. Thank you.
Hi, my name is Fuziri. I'm from Group A3. I'm here to present about steps to mitigate the risk. One of the possible methods of mitigating the risk in the VCM production plant is through a hazard control program. A hazard control program consists of all necessary steps to protect workers from exposure to a substance or system, the training procedures and monitoring workers' exposure and their health towards hazards such as chemicals, materials, noise, and vibration. In the case of leakage in Stream 1 and Stream 2, carrying ethylene and chlorine feed, hazard control program includes engineering control, administrative control, and personal protective equipment. In engineering control, the feed stream of ethylene and chlorine should be enclosed by ensuring that the inlet and the outlet of the pipe stream is being sealed to the connection and only open when maintenance is being done. Next, the bubble column reactor should be isolated isolated away from human contact, and only authoritative personnel is allowed to do the maintenance at a scheduled working hours. Ventilation helps to prevent the accumulation of hazardous gas in the plant, which might favor explosion and gas poisoning. Next, administrative controls limits workers' exposure by scheduling shorter working period in contaminated areas and also by implementing a few rules for the workers to follow. Such rules include restriction of tasks only to those who are competent or qualified to perform the duty, scheduling maintenance of the plant's equipment when there are less workers, and limit the exposure time of worker towards a hazardous unit through job rotation schedules. Workers should also be given training to ensure that they know how to protect themselves and those around them, such as emergency response towards fire, spill, and employee injury. Lastly, workers around and within the peripheral of dangerous sites should be given personal protective equipment (PPE). PPE includes respirators and protective clothing such as gloves, eyewear, and boots, which is able to separate workers from being directly exposed to hazardous chemicals or material. Workers should also be constantly reminded to wear PPE at all times whenever they are handling hazardous materials.
So, to conclude our project, vinyl chloride monomer is a colorless flammable gas at room temperature, and it's mainly made to produce vinyl chloride PVC. And in this project, we discuss about the worst case scenario of stream 1, 2 and 3 and a bubble column reactor tank, which is R101. In the first case, we can conclude that from a leakage of stream 1 and 2, 100% of people around it will face mortality, and the explosion also will cause 100% mortality to the operators around it due to lung hemorrhage or eardrum ruptures. And for the second case, the probit analysis shows that 100% people will face mortality due to chlorine gas exposure, and also 88% will face mortality due to ethylene gas exposure. And due to an explosion, the results show that there's no death and less than 27% of the people exposed will suffer from eardrum rupture. Therefore, what this means is out of 40% of the 40 staffs that works, 10 or less of them will suffer from this incident. And those in the residential area will not be affected. And to discuss about the possible ways to mitigate the risk are by implementing hazard control program or engineering controls through implementations of enclosure and isolation, administrative controls which limits workers to exposures by having a schedule of their work time or by implementing the rules, and also finally making sure that everyone who works there has their own personal protective equipment, PPE.